Lesson 4-6, Add Expressions. In this lesson, we're going to learn how to add expressions that represent real-world problems. Let's first consider the essential question for this lesson. In this lesson, the essential question asks, how can properties of operations be used to add expressions? Example 1, add expression by using properties. Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? So the first thing that we have to consider is, what is the expression that represents her rock climbing fees and her health club fees? So when we look at her rock climbing fees, it tells us that she has an initial fee of $65 plus she has to pay $40 every month. When she joined the health club, she had to pay an initial fee of $80 plus she has to pay a membership fee of $50 every single month. So the expression 65 plus 40M represents how much she spends each month on her rock climbing, and the expression 80 plus 50M represents how much she spends at the health club each month. So in order to find the total fitness cost after M months, we have to combine these two expressions. So here's the first expression and the second expression, and we're going to add them together. We're going to use the commutative and the associative properties to rearrange and regroup our values in order to put like terms together. So you'll notice that in both expressions we have constant terms of 80 and 65. And likewise in each expression we have variable terms like 50M and 40M. So we're going to combine our constant terms, 80 plus 65, and we get $145. Then we combine our variable terms, 50M and 40M, and we get 90M. So the expression that we can use to represent the total cost that Delilah pays each month after M months is 145 plus 90M, where the 145 represents the amount of her initial fees that she has to pay for each club, plus $90 each month to belong to both the rock climbing gym and the health club. Now I'd like for you to look down at the try it. Sophia and Ollie each deposit $120 to open a joint account. They each make monthly deposits as shown. What expression represents the amount in the accounts after M months? So in Sophie's case, she deposits $120 plus she makes $150 each month in payments to that account. Ollie deposits $120 and then he makes a monthly deposit of $135. And when I take that 135 times M, or the 150 times M, then what I'm talking about here is the amount of money each month that goes into those accounts. So we're going to add together 120 plus 150M plus 120 plus 135M. So here in our first row, we're going to rewrite those expressions and then group together our like terms. So Sophie's deposits look like this, and Ollie's deposits look like this. Now let's regroup our terms to show the like terms together. So we're going to put the constant terms together. Those are the $120 deposits that each of them made. And then we're going to put together the variable terms, which have the M, or the number of months since they opened that account. So when I put the terms together that are like terms, I get $240, which is how much went into the account between Sophia's deposits and Ollie's deposits, plus we get 285M, which is the amount of money that they are putting into that account each month. Now let's take a look at example 2.